You really already do this, you just don't really know that you do it. Okay, so when we factor completely, what that means is we factor, for instance, if I asked you, nope, this. If I asked you to factor that, what would you tell me?
X squared.
Oh, wait, X squared.
It's a special pattern. It's x squared minus 4 times what?
2.
Oh, no.
Oh, wait, no. It's the power of 2.
Plus.
Oh, wait, plus or minus? Plus.
Why? Oh, because
It's a difference of 2 squares.
Oh,
See?
dear. I forgot about it.
Okay, so factoring completely means that we factor it like this. We factor what's given, and then we look at the pieces that we've already factored, and we analyze each one separately and go, could I factor this one again?
Yes.
Oh, yes, I could. X squared minus 4 is also a difference of 2 squares. How does it factor?
X minus.
How about x squared plus 4?
X plus 2. Meaning X.
no. I don't even understand
No.
what that.
No. It's not a difference of 2 squares. Remember, cubes can be, wow, thank you, James. I was so hungry. I'm glad you brought us all lunch. Let's look at one. The difference now is we're a little bigger than just quadratics. We're actually into polynomials now. So let's say I had
Oh, no.
2y to the 5th minus 18y cubed.
Can't do that.
Remember, it's factor. So what's the first step in factoring?
Take out your common.
Take out a greatest common factor. Should you have one? Do I
Yeah,
have one?
because you get 9 and you get 3.
And then
What? So what is the GCF?
2y to the third.
2y to the third. What is left when you take out 2y to the third?
Y squared minus 9.
Y squared.
Minus 9.
And then you have
Now I have a difference of 2 squares, and since I'm factoring completely, I need to pick that up and factor it. So how do I factor what's in parentheses there?
Y minus 3y plus 3.
Is it factored completely at this point?
Yeah.
Yes.
Yes.
Now, if you look at the parentheses, none of them can be broke down any further. Does that make sense? Okay.
Now that.
Sometimes we have a polynomial in what we call quadratic form, meaning it's not a quadratic, but it's very, very similar. Okay, and here's what happens.
Why is it not a quadratic?
Because the exponent can be bigger than 2. Remember, quadratic's the biggest exponent's a 2. This one, the exponent that you start with here can be any even number. Okay? But the middle exponent has to be half of the first exponent. And then I just have a constant on the end. That's what it means to be quadratic form. Okay? So, okay, but standard form of a quadratic is ax squared plus bx plus c. So now we're in quadratic form of any polynomial, and it just means there's 3 terms, 1, 2, 3. The first exponent's even, the middle exponent's half of that. That's all it means, okay? If that's true, you can factor it the same way we have been factoring quadratics all along. Okay? So let me show you. Slow down. All right, here we go. Let me show you an example. Let's do. I'm going to do one that's a power of 4. Yeah, let's do this one. 4x to the 5th minus 40x cubed plus 36x. Let's factor it.
4x.
What is it? 4x? Okay, so if I take 4x out, tell me what is left.
X to the 4.
Minus
10
10x squared plus.
Plus 9?
Is it in quadratic form?
Yes.
Yes.
Yes. Can I factor that?
Yes.
Let's try. I don't know yet. I'm going to try. So the question I'm asking myself is, I've got 9 and 1 up front. Are there any two values that multiply to 9 but add to negative 10?
Negative 1, negative 1.
Negative 1, negative 9. Do we all agree?
Yes.
Well, because the x squared is already on there, whenever I write it, then those terms need to be negative, and this was, we said 9 and 1, negative 9, negative 1. It needs to be, oops, that's a 4. 9x squared and 1x squared. Do you see that?
Why?
A 4.
Why does it need to be?
Because it's got to still add back up to 10x squared, so I've got to keep the x squareds on there. All right, so I'm writing a slash, right?
Yes. I said that.
Wait, can you explain why it's?
Drew, you got this?
No.
Well, put that away, please. Say again, Evan.
Wait, why is it 9x squared again? Because it's negative 10x squared.
Yes, so when you add them together, it's still got to be the x squared. All right. Look at the first two. What? What's wrong, me? Oh. Me? Angry? I'm not angry. I'm not angry. I thought they were asking me a question.
No, we were talking about how we can comprehend.
Like everything's just going in one ear out the other.
Okay, look at the first two terms.
Got it.
GCF, what is it?
Wait, why is it 4? It's a 4 too.
X squared, it's a 4. X squared on the first two. Come on,
No,
Pen.
but in the water, is that a 4? That's a 4.
This is when we really, remember I was telling you about how chapter 1 is like
Foundation.
the foundation. We're building on that now, if you can not tell. So if you can't factor,
You're screwed.
Oh.
yeah, you can't do this for sure. That's why we spent so long on chapter 1. Yes, Drew.
How are you taking x squared out of? Because you can take.
I'm slashing it, I'm only taking it out of the first two. Okay, so it's gonna leave me with x squared minus 9. Are we all in agreement there?
Yes.
Yes, ma'am.
Keep the middle sign. What can I take out of the second two?
Negative 1.
What's left?
X squared.
All right, yeah. The 4x sits on the outside. I have x squared minus 9. This is a great problem. I love it. X squared minus 1. Do we all see where those terms came from? Okay. X squared minus 1 was my repeated factor here. X squared minus 9 was the repeated factor. X squared minus 1 was what was left. You thought I came up with this one off the top of my head? If I did, I would be patting myself on the back right now. I'd be like, you are awesome. Okay. So my question is,
Yes, you can factor it
can I
out.
factor anything further?
Yeah.
Yes. X squared minus 9 is clearly
That's difference of
difference of two squares, x minus 3, x plus 3. How about the x squared minus 1? Do I leave it or do I do it?
Do it.
Do it. Do it. Is 1 a perfect square?
Yes.
Is x squared a perfect square?
Yes.
Is there a minus sign in the middle?
Yeah.
Do it. Yes. If you don't do it, it's not factored completely. Okay.
Wow.
So look how this factored. Look what we started with and look what we have. Okay.
Why are we getting bigger? What is the point of doing this? It's easier to solve.
Because dividing and factoring are one and the same. When you divide by a factor, you get another factor, and we're going to talk about that later. It's setting us up for division of polynomials.
or setting us up for failure.
No. All right, I have two special patterns to show you. These are strictly, actually I have, it's kind of, grouping is a pattern, but we group when we factor anyway. You just haven't grouped with multiple variables, but that'll be a cinch for you. But I want to take some time to talk about the other pattern. And this is just, This was just quadratic form, so it's just regular old factoring. The exponents are just bigger.
Oh,
Wait till you see this one.
Some.
All right, here's where you are going to have to keep things straight in your head. Huh? Clear a little bit of room in that brain of yours.
The cubes.
Some in have more room than others. Some in difference of 2 cubes. Okay.
Dang.
Some of us got it and some of us didn't. That's okay.
Oh, say it how it is.
All right. Somebody first, before I show you the pattern, tell me what a cube is.
where?
Give me some guys, let's stay on track so we can get through this after 1 o'clock. All right. Somebody give me an example of a perfect cube.
Or X cube.
9x cube. No.
Oh.
No.
perfect
20, you got
cube would
27x cube.
27 would work. Give me another one.
I don't know.
Why would that work?
8 is a perfect cube.
64.
64 is a perfect cube. All right.
125.
Everybody, now some of you are getting it and others of you are going, what in the world are y'all shouting these random numbers for?
Yeah.
2 times 2 times 2 is,
8.
so 8 is a perfect cube. 3 times 3 times 3 is,
27.
which is a perfect cube, okay? So you're going to need to be able to recognize these, first off.
16 cubed is 216 times 216 times
Which is a perfect.
what'd you say?
I already said that. 125. 260.
At least through 6. 6 is probably at least recognized through there. You might encounter a few 7s, maybe a 10, and those are just the
Oh, yeah,
zeros on the end.
10.
But other than that, yeah. All right, so let me show you. So this one, remember with squares, we only had difference of 2 squares, right?
Yeah.
Because you can't take the square root of a negative number. There's some restrictions with radicals. Well, cubes are different because you can have the cube of a negative number and get a negative back out, right? And you can cube a positive number and get a positive number. So we got some sign differences here. So we can do the sum or difference of 2 cubes. So here's how it works. If I have 2 perfect cubes, and I'm going to do a plus, and I'm going to do a minus, because the pattern is exactly the same for both of them. The only thing that changes is the signs change up a little bit. Okay? Here's what you do. Again, this is a pattern you just have to memorize. I can already hear the whining now before I even put it up. Set yourself up a parenthesis for a binomial and a parenthesis for a trinomial. Binomial means 2 terms, trinomial means 3 terms, okay? I'm going to do my signs first, okay? My signs are going to be same, change, plus.
I don't understand.
Change with a plus on the end.
My signs inside these parentheses, binomial, trinomial, same, change, plus.
Okay.
Same, change, plus, depending on if I'm a sum of 2 cubes or a difference of 2 cubes. Okay? So your first step is to set up those signs here, yes? Is everybody okay?
So the last one's always gonna be plus?
Yes, the last one's always going to be plus. It's kind of like when we were working with a perfect square trinomial,
Every time.
and that second sign's always plus. This sign's always going to be plus. All right. I should have paused that video a second.
Always been sticky.
All right, in the binomial slot, we're gonna put what multiplies to give us this first term to the third. So I'm gonna call it A. Okay. If A cubed was 64, then what would A be? 4. Okay. Second one's gonna be B. Top and bottom same. Okay.
Must be so funny.
Pattern. Here we go. Square the first.
Cube the second.
Nope.
Understand.
Multiply them together. Square the last. That's the pattern. Same change plus A and B, and then square it together.
Same thing on the bottom.
Yep, same thing on the bottom. Now, of course, I'm going to go over several examples with you.
Thank you.
Is that all we're doing after we do these?
I need to show you a grouping. I don't think we're going to get to solving today.
Awesome.
Yeah.
On the bottom, minus plus plus.
Because if it's a difference of two cubes, the signs go same, change it, plus. It's always same, change, plus. All right. Let's do an example. I'm giving you a paper now as a reference. You might want to keep up with this. It's probably going to be your... Huh? No, I didn't hole punch them.
I just didn't want to carry this thing around.
Yes.
Okay, I have, we'll start easy. X cubed plus 216. My question to you, is that a special pattern if I'm asked to factor that?
Yes.
Yes. What's the pattern?
6. I mean, the
Sum of two cubes, right? So when it's a sum of two cubes or difference of two cubes, I set my little parenthesis, big parenthesis. Okay? Same change plus. Same change plus. What times itself 3 times gives me x cubed? What times itself 3 times gives me 216? Square the first one for the first spot.
6x.
Put them together in the middle.
You square it at the end.
Square the last one for the last spot.
It's 6.
And then what do we do that?
It's done.
Oh, never mind.
That's it. That's it. It is literally a pattern to memorize. Okay? I got this. I got it. It might get a little bit harder if there's a leading coefficient in front, like 8x cubed minus 27. Is that a pattern?
No.
Oh, is it?
Oh, yeah, it's just because I didn't figure out the 8.
The
So
8.
it'd be like
So,
2x?
yes, the first one, 2x times 2x times 2x is 8x cubed. So again, little parenthesis. Come on. Come on, little pig. You can do it. Little parenthesis, big parenthesis. Same change plus. What's wrong? No. What multiplies 3 times to give you 8x cubed? What multiplies 3 times to give you 27? Square the first one for the first spot. 4x squared. Put them together. 6x. Don't worry about signs. Square the last one.
9.
It's factored completely. Okay? That trinomial on the end looks a lot like a perfect square trinomial, but what's the problem? Why is it not?
6 and 6 don't add up.
The
It's
middle,
like, yeah,
the
you
middle
can't
is
add it
like
to the
double.
middle.
The middle's not double, right? It doesn't square dance. The ends are perfect squares, the signs satisfy the requirement, but 6 times x doubled should be 12x. So it will not factor any further for you is what I want you to get from that. Okay. All right, let me show you the grouping quickly. Last one for today. We'll save solving for Monday because some of the solving get a little involved with quadratic formula and whatnot. So now I have minus 16x plus 48. I'm asked, what's wrong, Isis? Okay. This is a cubic. Okay, it's bigger than a quadratic. It's a degree higher. So as I look at this, I'm asked to factor it completely, and from now on, when you're asked to factor, you always assume that it's completely, which means looking at the pieces you've got and seeing if you can factor them any further. So here, I'm asked to factor completely, bigger than a quadratic. The only thing you know right now is sum or difference of two cubes or quadratic form, right? It's definitely not quadratic form because there's more than three pieces. And the exponent's not. Well, what I'm going to do, actually, you're close. You're close. I'm going to slash it just like I do my regular factoring problems, okay? And watch what happens when I slash. And what's left?
X minus 3.
And that's why I said y'all should be pros at this part because this is the method we use to factor anyway. Minus 16, what's left?
X minus.
It does group. How do I know it groups at this point? They share that common term, that common factor there, that x minus 3. Yes, you can. Good job, Cullen. All right, I'm going to do the x minus 3. He's looking ahead. He saw the difference of two squares there and said you can do that again, right? You absolutely can. So that would become... That is correct.